Be saved. Thanks for the reminder. So yeah, we're talking about algorithms. I think we've mentioned this before, but algorithms are about, as I was saying, they're about putting our solution and our problem. So first the problem, then the solution, because in a logical sort of sequence that can be solved by a computer. And so I use the word sequence there very purposely because that is one of the components of algorithms. Algorithms are represented in this 4-part diagram by this in the bottom right corner, which is actually showing a thing that we call a flow chart. And that's how we'll end up our lesson, just looking at that in a minute. All right, so an algorithm is, as it says, it's a process of rules that can be followed in calculations or other problem-solving ways, but especially by a computer. How do we represent an algorithm, or how do we show an algorithm to somebody? Well, we do that in multiple ways. Not all of them are mentioned here, but some of them are. We can use plain English. We can just write down what we're saying. Very closely related to plain English is pseudocode. Pseudocode is kind of English-like. And then there is a thing called a flowchart, which we use as well. So what do algorithms contain? They contain instructions, actions, processes, programming constructs. Programming constructs can include the decision points, can include operations, can include, well, yes. Would I say they can include data stores? That's really when you're getting into data flow diagrams. It should have a clearly identified start and end. If we're going to use a flow chart, which works really good with algorithms, then we actually use a little special symbol for start and end. But even if we're using pseudocode, we say start and we say end, and we indent the rest of the algorithm from there. They should be correct, obviously, and they should be efficient. Now we're looking at that, and you know, bear with me on the sort of game stuff that we're doing with codeorg. That's the way that you should be thinking about looking at it. It's not computer programming. We didn't want students in this course to get bogged down with computer syntax. We could have done that, you know, and throwing you into Python programming or Java programming or JavaScript. We didn't want to do that. What we wanted you to do is think in terms of algorithms. And so the code.org is really about that. It's about you seeing algorithms visually with that blocky code. So the blocky code, you get to see how you would put an algorithm together. And then you actually have an opportunity, which I'll show you in a second, but you actually have an opportunity there to see the code that how the computer solves that algorithm. So I would say, yeah, the blocky code is kind of like putting an algorithm together. All right, let's continue a bit here. So what do we do in an algorithm? It does have steps in it. If we, first we, oh, there's just words there. Yeah, please come. The points there are things that we've talked about before. Start with some kind of context and some abstraction. What we want to do is we want to have something simple enough so that it can be put in forms of instructions for a computer. So I mentioned that we use this word. Why? Algorithms and computers, sequence is one of the key factors in solving a problem. In other words, what I mean by that is you start at a point. If two lines of code are one after the other, the first one is performed first, the second one is performed second. So that's what we mean by order is the utmost importance. So here we have an example. If you're going to move this ball toward the exit, you're going to have a sequence of steps. This should look familiar to you if you've been playing with code, right? Code.org. We do a lot of that, right? Move forward, turn left, move forward 2 times. So the sequence is very important. You see that in code as well. That's what they're trying to. So I mean, I know it looks kind of kid-like, but it's really trying to get you to think in terms of algorithms, think in terms of step by step, so that when you get to writing your JavaScript code and your Java and your Python, it will be that you can focus on the syntax then, because you've already understood how to put a computer program together. All right, so the sequence is important with mathematics, of course. We see here all the same numbers, but if we get the sequence different, we're going to get a very different result. I mean, that's the idea, right? So if you have 2, you add 3 and multiply by 5, you get 25. If you have 2, you multiply by 5, you get, and then add 3, you get 13. Very different results because of the sequence. All the numbers that went into it were the same. All of the actions were the same. Multiply and add and multiply. The fact that we did those things out of a different order, that made things very different number. And you know that from your, you remember that we talked about the brackets, BODMAS, brackets, orders, or and then division, multiplication, addition, and subtraction last. Okay, oh my gosh, that's kind of small, right? All right, can you see it? You'll have to look closely there, but here we've got a couple of flow charts. I'm going to put away these down a bit so we can see it. I thought it would be a bit bigger. Maybe if you download the thing, you'll be able to see it. There is a link there. I didn't make up these flow charts, but this is where I got them from. So let's look at this first one. I told you in a flow chart, we have a special symbol to denote the start and the end. That special symbol is this sort of rounded thing. It can be a circle, can be an oval. This one looks kind of like an egg. And so that's the start and that's the end. They're the ones that are that shape. All the other symbols are, in this case, are rectangles or diamonds. So the rectangles are going to be processes and the diamonds are going to be decisions. And so the rectangles can have many arrows coming into them. They typically have only one arrow coming out, but they can have multiple arrows coming into them. But you'll notice that the decisions, they will have multiple arrows coming out, and that depends on what decision was made. So let's follow what's happening here. So it says here, okay, follow the arrow. Well, the arrow here, it's hard to see, I know, but this is the pointy end of the arrow. There's no pointy end over there. And so if you're going to follow the arrow, the only arrow leading out of this rectangle is into the decision box. Did you follow the arrow? Now that's how a decision box works. You will go to the yes if your decision is true. You'll go to the no if your decision is false. Did you follow the arrow? Yes. This is how flow charts work, right? We see the arrow is taking us to there. We can't go this way because that's an arrow going into this process. So we have to follow this, and that takes us to the end. Congratulations, you know how flow charts work. If we went the other way, we come here and we say, follow the arrow, and then we don't follow the arrow, right? All right, let's start over. Follow the arrow, takes you to there, right? All right, did you follow the arrow? No, I didn't follow the arrow. Okay, how did you get here? Actually, I did follow the arrow. So then okay, that's fine. You followed the arrows, you're done. I don't know how I got here. That's what that says. I have no idea. All right, so would you like to have another go? And so that's what we see here happening at this point here. This represents a loop. This is actually an error loop for error trapping. And we put that into programs a lot. Especially when we're getting data from input from our users, we'll put a loop back and to ask, okay, so we ask them to type a name and they type a number. And then we'll say, that's not a name. Please type a name. So that would be what we would do. We'd go back. If they made a mistake, we'd go back and get them to do it again. Right, here's another one, and I'm sorry, as I said, it looked bigger than this when I put it in the slide. This is about getting a discount. So what's happening here is this is a person who's visited a website, and where they're interested in getting something for online shopping or whatever. And then when they go to get a discount, they're offered a discount, but the discount has been dangled in front of them as a sort of a lure. so that they will become part of the database of customers, so that they can be contacted for other possibilities of us selling them stuff, right? And so we get to this process, and actually this here is what it is going to be some they're saying something to them, right? By subscribing to this newsletter, you'll get a discount code and regular updates. All right, and so this should be a decision box. So this, I shouldn't show you this one because this one, as I said, a process box should only have one arrow coming out of it. So what this should say, this should be a decision box, which would be a diamond like this. So people do put flowcharts out there, which are not very good. Sorry about it. That's right. So we have two arrows coming out of this. So this is a decision box. Over here, we're saying I don't want to subscribe. And here I'm saying, sorry, I want a discount code. And here saying I don't want to subscribe. And this one here, even though they don't want to subscribe, we feed them back to this so that they can still give us their information before we let them go. Again, we've got, this should be a decision box. What type of news? So if we want this news, we go that way and sign up for those things. If we want that news, we go that way. I can't believe I pulled down a flowchart and the guys weren't using the standards that we use. Never mind. That is more or less it for this class. I'm just going to summarize by saying in algorithms, we talked about here today, algorithms are about instructions that we can give, that we can solve a problem with a computer. Algorithms can sometimes be solved by people as well, of course. But we do use standards in the way that we produce our algorithms. We have this thing called pseudocode, which I'll show you some more of later. And we have flowcharts. And as I said, we do have standards with them. And I kind of showed you one that wasn't really up to standard. But we did see one that was. Sequence is very, very important. If we do things out of sequence, it doesn't work. Also, we have to be very careful about what of our symbols use. And so maybe by showing that negative example with a positive example, that'll make sense to you. All right, so I'm going to stop that just now. I'm going to stop the share. I'm going to close the PowerPoint. And what I want to do is I want to share again. And then I should be able to get us to code. All right, so still there. Go to the home. And so I just want to show you a little bit about code. You guys should be working along nicely in code. Anybody who isn't, what I want you to do is I want you to navigate to code.org. And I know when I say anybody that isn't, because I know that people in this class haven't yet. Navigate to code.org, and then you're going to have to make an account. You won't, you can't really sign in unless you've sort of been there before. But you'll be able to make an account with Google. I want you to give your email address, and you choose your own password. Perfect. Yeah. Sorry. Yeah. If you made an account, that's good. That's all I was asking you to do that. So if you've made an account, you should show up as one of these 9 people. So these are the ones that have made an account. We can see that. And so Adil, Donna, Haya, Jane, Maha. So the rest of us, I'm going to really encourage you to sort of get onto that now, make that account. Now, the thing is, I can see what their progress is. And to be fair, we maybe haven't pushed that as much in this class, but we really need to get going on that. So I want you to sort of focus on that now for the rest of this lesson, certainly. And we'll be looking at that for our coming up lessons as well. Sir, I haven't made an account. Maha, I can see your account. There it is. I can see your account. And I am recording this, so you'll be good. So you've made an account. If you've made an account, once you've done that, you'll see come up. So let me just go back. You'll see come up this part of your page. And in this part of your page, you'll see your lessons. So I can view the course or continue lesson. I'll view the course because I'm at a stage in the, so you can see the green means that I've completed those. Oh, looks like I didn't complete that one, so maybe I should, but let's just pick one up here. So if you started it and you haven't done it yet, there are videos that explain how to do everything. I'm not going to go through the video, but you can do that if you want. Let's just take a lesson. So you need to do all the lessons, right? This is a pretty simple lesson, right? So what's happening here is we have to rid this diagram of this non-halal animal. And so what that's going to require is you to go forward 2 times, then you're going to turn left, then you go forward 2 times, and then you're going to, yeah, that's it, right? So that's the program right now. What you've got is you've also got, should be able to see the code. Yeah, there it is. So we can see the code at any time. Now that code is written to be syntactically correct. I believe this is JavaScript. And so JavaScript has some inbuilt libraries or some libraries that work with it. And so there's some code. This is a kind of a silly one because all it is doing is sequence. This is sequence, very important sequence, but you know, it goes ahead and does that. So you need to be doing that too. And you can show the code afterwards as well. Let's see if we get a lesson a bit nearer to the end. Something that actually does something. Yes, now we get into something. Now, what you can see here is we got a lot of stuff going on in this program. This is my solution of the program. Yours might be different. But what the idea here is this bird has to come and remove this. So what he's going to do is he's going to go forward 1, 2, 3 times. So that's why I got to repeat here and move forward 3 times. Now, how you do that is if you start building a program, you can move things around, but the only way you can move them around is you can pull something down and it frees up the thing above it. So that's how that works, right? So now I can do something with these. I can pull this out, right? And that's how I put that in there in the first place. Now, if you've got a repeat that's doing a lot of stuff, do I have any that's doing a lot of stuff? No, all these are simple repeats in other programs. Now, notice it's gone light colored, not dark colored. That's because it's not joined up. So the whole program has to be joined up for it to sort of work. Okay, and so come back. There we go. So how this program is going to work, it looks like the bird's going to go forward 3 times, and it's going to turn right, then it's going to go forward, then it's going to turn left, then it's going to go forward 2 times, it's going to turn right again, then it's going to go forward 2 times, and it's going to turn right again, then it's going to go forward 2 more times. And that's how that's happening here. So repeats, I like repeats. It makes the program have less lines of code. And so I mean, I know that looks kind of silly, but maybe this doesn't look so silly. All right, so what you got there is you actually have some real programming code. You don't have to write this, right? You're doing this the way we're doing it here. It writes it for you. This is just showing you what's going on in there, right? So what's going on is you got a proper loop going. You got a loop going here that goes 3 times. That's what that means. You start at 1 and you go until you're and you don't go to 3. You go 0, 1, 2. That's 3 times. And what this means is you increment or you make it bigger every time. So you start off with 0, then you go 1, and then you go 2. What do you do every time? You move forward. So that means you move forward 3 times. Then you turn right, then you move forward again, then you turn left. This is the bird moving along, right? And then you're going to do this move forward thing 2 times again. I just got tired of typing out move forward all the time, so I put a loop in there. I think that, yeah, you don't have to do that. You could do the program without the loop. Actually, I found that when it was sort of marking the answers for me, it seemed to prefer not the loop. But I think it's a good idea to do it. I just see, yeah. Anyway, so can't seem to see the whole thing in this case. Why? Maybe if I reduce the size of my, yeah. And then you you've got another loop of 4 times at the end. Oh, sorry, 2 times at the end. Now maybe I can get out of that. How can I get out of that? Out of that program. So maybe if I just go back to here, will that do it? Yeah. So go back to there, go to the course. Maybe we can get something a little bit more exciting than that. Okay. Debugging the maze, that wasn't collecting treasure. Yeah, so if we go up to, the creating art, that's a little bit more tricky. But if we go up to, say, lesson 3, you guys will all get there eventually. No, that's not too very exciting. It's kind of like what we did a minute ago, right? Same. Oh, well, actually, no. So what we've got here is you can actually put a block of code, which is more than one line of code, into a repeat. So a repeat doesn't just have to have one thing in it. It can have multiple things in it. And so that's what we've got here. If you're going to do that, what you do is outside of the bit that you want to repeat, you put the, what was that? It was move forward and turn right or collect or something. I think it was move forward and then collect. So if you're going to do that, you build up your bit of code that's going to be repeated outside, and then you slot it into the repeat. And then you choose the number of times you're going to repeat it, right? And you need to get that right. And then you can run it. And so this one is collecting diamonds. All right, so I think that's enough to get you started. So I'm very interested, of course, in how we're doing. So I only got 11 people. So there must be some people out there who haven't joined yet. It's, you can see if you join. Now, for people who haven't joined, this number is very important. When you log in, you'll be asked for a six character code. That's it. For our class, it's ZXK ZBM. That's how we log in. That's how we get to this program. So with this program, by this program, I mean Express course. We need to be in our Express course. Don't be in section 13. If you use that number, you'd end up on their course. So we want this, not the number. If you use that code, you end up with them. You need this one. All right, so I'm going to stop sharing now. And maybe I'm going to, well, I'll stop recording.